So the second part of learning about angles here that we're going to talk about is the angle addition postulate. And remember, when we talked about postulates before, a postulate is something that you cannot prove. It is something that is just accepted as fact. And so one thing that we also call a postulate is also called an axiom. And I want you to get familiar with that term, especially if you're going to take upper level math. Axiom, axiomatic thinking, those are things, methods of proof that you're going to use. So anyway, a postulate is something that just we know to be true. We don't prove it. So the angle addition postulate states, if a point, and in this particular example, it just randomly picks R, P, Q, and S. If R is in the interior, so we're going to take this point R, okay, and I'm trying to remember my color coding. So I'm going to take this point R, and I'm going to put it inside this angle, QPS. Now, angle QPS, what does that mean? That means P is my vertex, right? And QPS means I'm going to go from Q to P to S. So I've got this big angle right here, okay? That's angle QPS. And I'm going to take this point R and I'm going to put it in the interior, as so. What this says is basically, if I put this point in the interior, I can draw another ray and create two smaller angles such that the two smaller angles add up to the larger angle. So basically, this is saying that if the measure of angle QPR, let me go back here. It says, then the measure of QPR, now QPR, guys, that's this angle right here, plus, if you look up here at the picture, it's saying the measure of QPR plus RPS. Guys, RPS is right here because you're going from R to P to S. The two smaller angles added together, okay, once again, QPR, QPR, that's angle 1, plus RPS, that's angle 2, RPS. When I add those two together, it's going to equal QPS. And what is QPS? It is the entire angle. It is the full angle right here. That is this whole angle here. So basically, the angle addition postulate states when you have two smaller angles, or when you have a big angle, and you put a point inside of it, you can draw it and separate it into two smaller angles. And when you add the two smallers, then you get the bigger one. The other part of this, this other statement that you see here at the end, just so we don't leave this unaddressed, is just basically saying by the converse. Remember converse? The original statement is if P then Q. The converse is if Q then P. This is saying by the converse, if you can show that these two angles add up together to give you the bigger angle, then that implies that R is in the interior. The original statement says if R is in the interior, then these two smaller angles add up to the larger one. The converse says if the two smaller angles add up to the larger one, and then R is in the interior. And it's only because you only know R is in the interior because R is a part of the name of both angles, and we'll get to that a little bit later. So let's come down here and let's apply the angle addition postulate. This says the measure of angle PQS is 77, and we're going to learn how to follow these angles. So PQS, this little M right there, measure of angle PQS. And again, you can write your angle symbol like that or like that. I like putting that on there. That's just the way I do it. PQS goes from P to Q to S. It's telling you that this whole angle is 77 degrees. Now, normally, I would write the 77 on the inside of the angle, but because I've got two other smaller angles here, I'm going to write it on the outside. Then it moves on to tell you the measure of angle PQR is 32. PQR goes from P to Q to R. That's 32 degrees. So find the measure of angle RQS, which is from R to Q to S, which is this guy right here. So you can see why I wrote the 77 on the outside, because it would have gotten in the way. So the angle addition postulate, remember, says I've got a point in the interior, the two smallers add up to the bigger. So I know that 32 plus x is going to equal 77. And I just solved this like an algebra equation. And some of you could probably even skip and not even have to set it up like this. You could skip right to the subtraction. So I end up getting x equals 45. And that's how you use the angle addition postulate. You really didn't even know you were using the angle addition postulate. You just reasoned it out, but that's basically the principle. So let's move down here and look at a couple more. If the measure of angle, and let's keep in tune with how I did the colors. If the measure of angle AOC, so that's from A to O to C, is 70 degrees, so this whole guy right here is 70. And again, normally you will write the angle measure on the inside, but not when you have a bunch of overlapping angles. Sometimes it's easier to write it this way. And let me scroll up. So we did red and then green. And the measure of angle AOB is x plus 10. So this guy right here is x plus 10. And sometimes you'll see it written like this. Guys, that's not to the 0 power. That means it's just implying that x plus 10 is the number of degrees. So don't look at this and think it's some kind of funky exponent. It's just implying its degrees. And then it says the measure of angle BOC is x. So this guy is x degrees. Let's apply the angle addition postulate. Angle addition postulate says the two smaller ones, because where's my interior point? Right there. B is in the interior. So I've created two angles, x plus x plus 10, and you don't have to keep the parentheses and the degree sign on it. Remember, that's just there to let you know that it is an angle. It's not some kind of special operator. Is going to equal 70. So from here, we just solve it out. X and x are like terms, so I've got 2x plus 10 equals 70. And then I'm going to do a subtraction to get the x by itself. We're just following the algebra algorithm. And then for my last step, I'm going to actually divide both sides by 2. And x is equal to 30. Now, we've just solved for x. X is not a degree. It's not an angle measure. X is just a value. But we need to know what x is so we can find the other angles. So let's go back and take a look. BOC, remember, was x, right? So BOC was equal to whatever x was. Well, what is x? It's 30. So BOC actually is 30 degrees. And then AOB was x plus 10. So it's equal to x plus 10, which would be equal to 30, which is x, right? Plus 10, which is 40 degrees. Now we're done. Am I spending a lot of extra energy solving things that you could probably trivially do in your mind with some of your mental math? Sure. But I want to map this out so you can see it procedurally and know how to solve it properly.